Thank you for the introduction, and thanks, Leslie, for your exciting presentation. So as it was said, this is kind of a preliminary finding for a 3-year project. So the project was supposed to start in 2019. The funding was secured, but because of COVID, we didn't collect data for plant biomass in 2020. So this data is biomass in 2020, 2021, 2022, and then seed samples 2020, 2021, and the 2022 sample is still in the process of completion. So as I was introduced, the key collaborators on this project are Fran Rich, Lyle from Nutrien, and John Head from Manitoba Ag. So this is a Prairie Province wide project, so Saskatchewan, Manitoba, and Alberta. And as I said, it's a preliminary finding for what we have done so far. So thanks to the agronomists for Nutrien, the Saskatchewan Agricultural Ministry crops specialists, and then many individual farmers for allowing us into their fields to collect samples. So a bit of background to the project. So the nutrient uptake. So when we say uptake is in the whole plant, and then removal is looking at just what is in the grain. It's been a useful tool for farmers and agronomists in setting fertilizer application rate and setting yield target. And then in 2001, the Canadian Fertilizer Institute compiled the data for nutrient uptake and removal in major crops. But when we look at the data, it's kind of a tool. It's not like a standalone tool, so you still have to do soil test and complement that with the nutrient uptake data. But how it started, when we look at this, this paper, I think everyone has seen or used one before. The actual data it says revised in 1992, so which means it's in the 80s, and this is a revised version. But when we look at what we had in 2001, when we look at the values critically, it's plus or minus 10% of this 92 revised version. So it's been the same data that has plus or minus 10%. But we thought with new genetics, different management practices, we don't know if those values still are applicable to the current situation. So that was kind of the import of the study. So this is the 2001 compiled data, which is a revised version of the revised 92 version. But we know agronomy, they've changed. And then when you look at the yield on it, when you look at wheat is 40 bushels. And I don't think like farmers are aiming for more now, and 40 seem low. So we're thinking with improved genetics, higher yields, are these values still holding? So that's kind of the import of the study. And if we look at the IPNI compiled nutrient uptake and removal, when we look at the geographies they considered, Canada is not part. So are these values applicable to the Western Canadian prairies or even Canada as a whole? And then another one, the Mosaic nutrient removal app, all those ones were based on either the IPNI or the revised CFI data. So they are all kind of the same sort of data trying to use in different platforms or on different platforms. But we thought we should revise it to see if it matches or is different with current practices. So the current study, as I said, is important because of improved cultivars and then improved management. We have for our nutrient stewardship, we have best management practices, we have variable rate technology being implemented. So our fertilizer application rates, seeding rates, and all technologies have evolved over time. So are these values still relevant at this stage? So the objective of the study is to determine and revise the crop nutrient uptake. So we are looking at NPKs, boron, copper, and zinc in all the major crops across Western Canada. So we had the biomass samples, which you use to get the biomass with the grain will give us the total uptake. So the biomass the plan was to take 10 samples per crop. So we had 15 crops, so 150 samples. And then 2021 and 2022, that was when we took the samples because we couldn't get the 2020 samples. but the 2022 season is still in process. So that's kind of the breakdown of the biomass. And if you look at winter wheat, mustard, chickpea, and lentils, we didn't get our target for, ideally it's supposed to be 20 or more samples per the 2 seasons. But those crops, we didn't have much. So if you look at 2021, we had 113 samples, 2022, 315, and a total of 428 samples. With the grain samples, so the presentation today is looking at the removals in the grain samples. So grain samples, the plan was proportional to the acreages. So in Saskatchewan, we might have more samples compared to other provinces based on the acreages per province. So in 2020, 2021, and 2022, we took samples. 2021, because of the dry spell, we took 20% of our target. And in 2022, the samples are still coming. So currently, we have 56% of our target, and hopefully we can get to the total numbers. So if you look at it, 2020, 21, 22, these are the total number of samples, and then categorized by different crops. So the current data I'm presenting as a preliminary is based on the 1,266 samples divided across the different crops. So this is how the samples were, the spread of the samples across the 3 provinces in 2021 and 2020 for the grain samples. 2022, as I said, we are still compiling, so we'll update this to see how wide we cover those. So once we receive the samples, usually we require farmers to send 500 grams of 300 to 500 grams. Once we receive those, we clean them to take all the stubble that came with the samples to make it really like a representative of the grain samples. We dry it to determine moisture, because in transit, sometimes the grain absorb moisture. So as we are taking it to the lab, we know how dry the sample was. And then once we have it, we convert it back to the recommended moisture based on the Canadian Grains Commission. So the sample is dry, clean, and moisture is taken, and then we grind them and do the analysis in the microwave digestion. And these are the relations we use to convert this into concentrations. So once we have this, that's pounds per acre, and we divide it by the yield to get the pounds per bushels as a concentration. So how we handle this, the data we received, 2020 was kind of a normal year. 2020 was dry, and 2022 was mostly normal. We have flood in Manitoba. And then because of the dry spell in 2021, we had a lot of residual fertilizer in 2022. So we're thinking, do we combine the data, or do we analyze them based on year to see if there's like different uptake based on the season? What we did was we just look at the data. So the top one, we just pick zinc, canola, like zinc and canola. So the first one, the all blue on my right, on your left, is kind of combined data. But when we look at what we have, the orange and the blue, you can see how the 2021 and 2020 data are kind of together. We didn't have any strict gradation between 2020 and 2021 to warrant looking at them differently. Like all of them were kind of related to the yield. So we thought if we combine them, it will give us more samples, to give us more statistical power to look at the data. And then when you look at the pounds per acre, which is the concentration by the yield, we can see in 2021, because of lower yields, how the orange bars were lower in yield, and then they spread out compared to the 2020 samples. So when we look at the data like this, we thought combining them wouldn't hurt, and then it would give us more power to make conclusions based on more samples rather than having 2020, 2021, 2022 data. So that's how we handle the samples. So first, we look at the grain yields with bushels per acre. Because the CFI was kind of a reference for this project, we compare what we found to the CFI published data. And then you can see our yields are kind of varied because of the different geographies we covered. And we didn't separate them by soil zones. We just combined everything. So we covered kind of a wide range. But if you look at the CFI data, that's the black line with dot, and then RS is the green bar. So DS is kind of just the median plus or minus 10%. But the yield, they had just one yield. They didn't have ranges. So we're trying to compare if their average yield matches with ours. And the average yield in ours was 17 to 33% higher than the CFI data, which proved that over time we have high yielding varieties compared to what the CFI used. And then oat, fava bean, lentils, and peas, the yields were within 10% of the CFI, so we think they were kind of comparable. Soybean was 22% lower in ours than in theirs. But we were thinking in 1982 or early 80s, I don't think if we had soybean in Western Canada, because they had compiled data for Western and Eastern Canada. So we're suspecting that data is more of an Eastern Canada data than what is typical to ours. So the grain yields in all the crop had wider variabilities, so to show the soil and climatic conditions covering our sampling areas. And with nitrogen, so for planning purposes, it's preferred to report crop nutrient concentration or uptake and removal based on the component produced. So if it's a bushel of crop, if it's a ton per dry weight or something. So we converted all our data to pounds of nutrient per bushel of crop. So this is nitrogen. And then we can see what stands out is with durum and chickpea, CFI didn't have compiled data for Western Canada, so there wasn't any comparison. But what we found, most crops had lower or similar nitrogen removals compared to the CFI data. The only standouts were the flax, soybean, and lentils. They were higher than the CFI data, but mostly were between or within 10% or even lower. That's for nitrogen. For phosphorus, cereals were generally higher in our results compared to what the CFI reported. Oilseed and pulses were lower in ours than what the CFI data, except in flax and lentils. With potassium, cereals were higher, oilseeds were lower, similar to phosphorus, but with pulses, it's specific to the different crops. And as I said, this is still preliminary and we are still compiling more data, so the trend might change. And then with sulfur, so sulfur were generally higher except in these 3 or 4 crops. So we found sulfur to be generally higher in our data compared to what the CFI reported. So the different nutrients might be different across different regions compared to the CFI data. So we have some that were higher and some that were lower. So there's no general trend across all the crop classes. So the conclusion for the macronutrients is despite the higher yields over time, most of the crops had similar or lower nutrient removals compared to the CFI data or estimates. And then what we have to know, the CFI data, the reported range of removal. So we didn't have details of where the samples were taken, how they were processed, and so that was the only sheet we have was just that one pager. So. And then with micronutrient, there wasn't any CFI data for micronutrient. But what we found was, if you group them by cereals, oilseeds, and pulses, they varied if it's boron, copper, or zinc. So oilseed had higher boron removal, followed by pulses, and with cereals having the least. But pulses had higher copper seed concentration than oilseeds and cereals. With zinc, we didn't have any clear trend. However, fava beans seem to have higher zinc removal. This is per 100 bushels. So if you want to interpret it, you have to consider the weight of the bushel. So a 60 bushel wheat compared to maybe a 48 soybean or something might be different. So you have to look at it from that angle. And then I made this heat map to try and see where we compare with the CFI data. So the positive and the negative signs show the direction of the change. Are we higher or lower the CFI compared to the CFI? And then the color shows the magnitude of the change. So the extreme red means our current estimate are higher than the CFI estimate, and the extreme blue, ours is lower than the CFI. And then the circles show removals that were within 10% of the CFI data. So we think anything within 10% after 2 decades or so is still kind of close to what the CFI is saying. So how do we use this data? As I said, it's not a standalone data. We have to use it with soil testing. Soil testing is still key. So if your soil test says you are within the maintenance zone, then your addition of fertilizer is equivalent to what is removed from the crop. So if you have your nutrient concentration, you multiply it by your yield, then you get the pounds per acre. And if your soil test shows your pounds per acre in the soil is within that, then applying what your crop takes out will kind of bring your soil into the maintenance zone. So each farmer or each farmer's field or each quarter section or section might apply it differently. So first, you still have to soil test, know where you fall. If you are within the maintenance zone, then what is taken off your farm from in nutrient concentration, you can add it so you'll be within that zone. But if you are in the other zones, if you are in the drawdown zone, then there's no issue. But if you're in the build-up zone, then it's on top of what you take out, you add more. So this is how you kind of interpret or how that can help you with the interpretation. So the take-home messages are, from this study, there's a consistent trend in yield increase. So we have yield increment over time in terms of bushels per acre and then pounds per acre. Higher yields in terms of pounds per acre means higher nutrient taken off, so you have to replace that. And the higher yields take more nutrient from the soil, as I said. So the finding here shows that maybe the newer cultivars are more efficient in nutrient usage compared to the older cultivars. And then the micronutrients removal, they vary across the crop classes. So the cereals, the pulses, and the oilseed have differences. And then the crops with higher nutrient uptake are likely first to show deficiency symptoms. So if you are pushing for crop rotation and you're adding pulses in your rotation, especially once you have faba bean in there, we can see the zinc removal and faba bean is more higher. So we have to pay more attention to micronutrient removal to see if we need to apply micronutrients or it's just not necessary. So the lower nutrient removal means farmers could save for fertilizer costs. Because if your soil test shows you are within the maintenance zone or you're in the drawdown zone, then applying just what your crop takes out, still you are good. So if you're applying more, then you can cut back based on your concentration or your nutrient removal to save some cost on fertilizer. And then now I'd like to acknowledge our funding partners. So all these agencies funded us, and then the collaborators with the Ministry of Agriculture, as I said, participating agronom site, the extension specialists, and then Nutrient Ag Solutions for their help. Thank you very much. And if you have any question, you can direct them to this email. The first one is mine, and the second one is for Fran, and we can get back to you with answers. Thank you very much. Any questions? Yeah, so we are in the process of finishing up the data, and then there will be a final report to the funding agencies. So the plan is to develop kind of an Excel or web app that you plug in your crop, then you can see, based on the yield, you see your nutrient removal. And then, so the finding is coming out as a report to the ministry or to the funding agencies, and it will be available online too, so you can have access to it. Yep.
All right, can I get a round of applause and thank you for Dr. Issah?